Hello everyone, welcome to my channel today. Today we are going to work on how to really score high marks in exam, okay, when it comes to differentiation and integration. Then I'll do a separate video on kinematics. I'll also do a video on small change and then rate of change, okay, so that every day we expect some questions on calculus, okay, differentiation, integration, and the applications. So when we have really mastered these things, I believe that it will help us gain higher marks in the exam. Now, for one thing, Cambridge has a particular way of setting questions. That is why I've prepared this worksheet for you. So you see a link to the worksheet in the description below. You can download it and then work with me alongside. Now, what I'm going to do is that I'm just going to solve the questions as I move on for about an hour, after which I'll just stop solving the questions because by then I believe you've had all the idea and the concepts that's necessary to solve these questions, okay? Then the next thing that I will do is that, for each of the questions, there is the particular year beneath it. So you can just work it out, go to the past questions, check the marking scheme of that year. If you got it right, great. If you didn't, then just put it in the description that, okay, this particular question, I'm having a problem with it, and then I would help you out, okay? Right, so let's start with the very first question. It says that a curve has an equation, so they gave us this particular equation. Now this equation is defined for all x values that are greater than 1 because if the x value is equal to 1, that particular rational function would not be defined, okay? Now what they really want us to do is to show that the derivative of this, okay, can be written in this weird form, okay? All right, so basically that's what we want to do for 5 marks. Okay, you may think that, well, we are going to do a lot of things per se, but this is not difficult, doesn't involve much. This is a fraction, so we are going to use the quotient rule of differentiation, okay? People try to keep this rule in mind, but no, it's not worth it, okay? Just let's do it together. You see how it's done. So you do dy dx, okay, is equal to, now the first thing is that differentiate the numerator, okay? So this will be 3 over 2, okay? Then you have 2x squared plus 10. Then you subtract 1 from that, and then you'll be left with half, okay? Then you go inside this particular bracket, okay, and you differentiate this, and that should give you 4x, right? Yeah. Okay, and then you bring the numerator. All right, you are not going to differentiate the numerator. Then you continue minus. Then you have now you have to keep the numerator constant. Okay, and then you now differentiate the denominator. Mind you, when you differentiate the denominator, you are going to get 1. Okay, divided by the denominator square. Okay, so that's how it's done. You keep one constant, you differentiate the other, minus, you keep the other one constant, differentiate, divided by the denominator square. Okay, so now we check this now. This will cancel this here twice, okay? So you have 6x into bracket 2x squared plus 10 to the power half, okay? Then you have x minus 1 here. Then you have this guy, 2x squared plus 10, and then you have 3 on 2 all over x minus 1 all squared. But now if you study the question, they want us to have some 2 to the power half, and then this whole thing. So that, okay, so really, this is the derivative. We have differentiated it, but the question says that we should leave it in this particular form. That is why we are going through the headache, okay, to do it in another form. But on any given day, this is just fine, okay? Now the question wants you to have 2x squared plus 10 all raised to the power half, okay? So that should be a common factor. You can factorize this function and that function, okay? So if I pull out 2x squared plus 10 all to the power half out. What will be left here is 6x into bracket x minus 1. Okay, and now I would also have, you may be wondering what will be left in the other one. Well, you see, if you pull 2x squared plus 10 all raised to the power half out of that, you should get 1, right? Okay, because check it, you have 1, this is 3 over 2 is the same as 1 plus half, right? So if you pull the half out, you are left with 1 basically. So what this place will be left with is 2x squared plus 10. Okay, then we divide all by x minus 1 all squared. All right, so let me clean this part. So the next thing that you want to do, okay, is to just clean this particular bracket up a little bit and you are good to go. So we, maybe I can write in blue because I'm going to write in this question. All right, so we have our 2x squared plus 10 all to the power half is here. Then with this bracket, should you expand this, you have 6x squared, right? Minus 6x. Sure. Good. So if you take this negative 2x squared, you subtract that from here, you are left with 4, right? So 4x squared. And then the next thing that we do is that you have negative 6x, right? There's no x term here to work with it, so you just write your minus 6x. Then finally, you have your you have your negative 10. Okay, there's nothing for you to work with here, so we just put the negative 10 there. All right, and then you divide by your x minus 1 all squared. Now take note of this. I'm going to copy it, and then I'm going to paste it somewhere here. Now if you check what we have written, that is exactly what they wanted us to get over here. Okay, we have everything, half is there, some A, B, C things are here, we have the denominator there. I mean, we've answered the question for our 5 marks. Nothing difficult, okay? Simple as that. Okay, so now the B part says that show that for x is greater than 1, the curve has exactly one stationary point. So let's underline that stationary point. Okay, so what do? We should find the value of x at the stationary point. Okay, so we know from our basic study of calculus that at the stationary point, okay, the derivative, the turning point is 0. Okay, so you are going to equate this whole thing, which is the derivative, to 0. So that means that you have 2x squared plus 10 to the power this minus 6x minus 10 is equal to 0. Now check this out. This part can never be 0. Never be 0. Never be 0. And I'm going to tell you why. Because listen, the x is a square number. That means that it's always going to be positive. Even if x is negative or positive, that value is going to be positive. So if you have a positive number here, okay, if this whole thing is positive and you add that to 10, it's still positive, and the square root of a positive is not 0. So there's no way that this part is going to be 0. Okay, never. So that means that it is only this portion that can be 0. So we can equate 4x squared minus 6x minus 10 to 0. Okay, so you have to state that this part, okay, the one that I showed in the exam, that it can never be 0. They give you 1 mark for that. That means that you know what you are doing. Then remember, it's 4 marks. So if they have given us 1 mark, it's left with 3 marks, and that is what we are going to work for. So now you can divide through by 2, right? So you have 2x squared minus 3x minus 5 is equal to 0. All right, and then you solve it. So that's negative 10, right? Negative 10, factors of negative 10 added to give negative 3 will be negative 5 and 2, right? Great, so let's work with negative 5 and 2. So we have 2x squared minus 5x plus 2x minus 5 equals 0. Now we can clean this here. All right, so that means that if we pull x out, we are left with 2x minus 5. And then this is, we pull 1 out, we have 2x minus 5 equal to 0. So we have x plus 1 and then 2x minus 5 is equal to 0, giving us x equals -1 or x is equal to 5 over 2. Okay, now remember that the question says, let me highlight that, for x is greater than 1. So if you look at your answer, this is not greater than 1, so that is not your value of x. Therefore, the value of x that you are looking for is x is equal to 5 over 2. Okay, so this is exactly what the question is looking for, and now you have your 4 marks, right? Like I said, pretty easy when it comes to calculus. I mean, nothing should confuse you. Okay, then we have this particular integration question to do. At a glance, when you see this question, you might think that, well, what do I do? Well, think of it this way. If we have the integral of maybe ax plus b, okay, all to the power c dx, what should you do? Always keep this idea in mind. You want to integrate the whole function, so you are going to divide by c plus 1. Okay, we always add 1 to it. So you have your ax plus b c plus 1. Okay, and then the next thing that you want to do is to bring the coefficient of the x term. Okay, bring it down here. So you have all this times a. So basically that's how to do it, and you have integrated it, maybe plus c if you want to. Let's call it plus d because I've already indicated the c in the question. Okay, where d is, I mean, of course, your constant of integration. So if I have this particular function, I'm going to write it this way, that the integral of 10x minus 6, minus 1 rather, minus 1 to the power -6, okay, dx. And now that would help me to integrate it easily as 10x minus 1. If I add 1 to the power, I have -5 divided by -5 here, okay? But the coefficient of the x term is 10, so I'll bring it down here, 10. That means I have, let me erase this guy here and then maybe go down here. So I have -1 over 50, okay? Then I have 10x minus 1 power of -5, okay? Plus c, of course. So you can also write it as -1 over 50 into 10x minus 1 to the power 5 plus c. All right. So remember that you have options here, okay? So take your time and do it nicely. Now, how about the second one? If you look at this, you may be wondering, whoa, this is, well, yeah. What I want you to do is to check it out. Can you expand? If the answer is yes, expand and see what happens. Okay, if you cannot expand, then you start to think of another way of probably going about the integration. Okay, right, so let's expand to see what happens. Now, if we expand, the numerator is going to be 4x to the 6th power, right? Okay, then we are going to have 20x cubed, right? And then we are going to have 25 all over x dx. Right, I hope my expansion is correct. Check it out for me if I've made a mistake. Sometimes I make mistakes in my calculations, and some of you just pointed out rightly in the description down there in the comment section, which is really good. I mean, I appreciate that. It means that you guys are really following. So, I mean, check it out. If I make a mistake, just reference the question that on this particular question you made a mistake, so that those who are watching would correct themselves, okay? All right, so I can simplify to get 4x to the 5th power, right? Yeah, and I'm going to have 20x to the 2nd power, and then this is going to be 25 over x. Why didn't I write it 25 to the, maybe 25x to the -1 power? Well, if you are about to integrate that, okay, you will see a problem, because if you have x to the power -1 and you add 1 to that, and you divide by -1 plus 1, you're going to divide by 0, which is not possible, okay? So it makes the whole issue really, really difficult. And whenever you have a situation whereby you're going to divide by power 0, you have to think of ln, okay? Something is happening. It's actually going to be integrated to get a ln function. In most cases, at least at the IG level. When it comes to A level, we will show you other ways of going about it, okay? So now we are ready to integrate this beautiful function. So the first part will be 4x to the sixth power, okay, because I'm adding 1 to it, and I'm going to have divided by 6. This I'm going to have 20x to the third power and divided by 3. Now here, check this now. If I have the integral of 25 over x dx, okay, I can put the 25 out, and I'm going to have 25 the integral of 1 over x dx. And now when you integrate 1 over x, your answer is ln x, so you have 25 ln x, okay. All right, now we put it in the absolute sign because they cannot, a lane starts from the positive side, okay, more than 0 going. It can never be even equal to 0, okay. So you just put in the absolute sign, telling you that whatever the value of x is, it has to be positive, okay. So that's the argument that you're having. So this is 25 ln x, okay, plus c. So you can leave your answer like this, or if you want to simplify it, of course, why not? You can write 2 over 3 x to the sixth power, then 20 over 3 to the third power, and then maybe 25 ln the absolute of x, okay, plus c, like that. And then why not? This is good. For how many marks? 3. Not bad, you know. Okay, so we are done with this question. That's a February 2-1 grade. Now B says that differentiate this particular thing. I'm not sure, but most of the time I think we have a formula sheet in the question. Let me check, okay, really quickly. Mathematics, let's go to past questions, add maths, maybe a current paper, maybe May, June, paper maybe 2-1. I want to show you something. Okay, so if you look at this session, you on your trigonometry session, let me get this thing. Good. You see, they have given you these things, the identities that you use in trig functions to. Please pay attention to the formula sheet. But what I really want us to check is if they have given us the calculus part where when you differentiate something, you get another thing. Well, unfortunately, Cambridge will never give us that, okay? So that means that you have to learn it on your own, okay? All right, so, I mean, you have some learning to do. So now let's do it. If they want you to integrate this guy, so the question is, if I integrate tan, what do I get? It's something that you must know before the exam. Don't go there if you don't know. Okay, so if I differentiate tan, I'm going to get sec square. Okay, sec square this. All right, but now you are not done. You go inside the bracket to differentiate, and that will give you 3. So your answer is basically 3 sec square 3x plus 1. Okay, beautifully like that. You are done. And now they said, and hence, the hence there, okay, means that this particular question that you're about to solve is highly related to the previous one. So don't just see it and you are like, oh God, what do I do? What do you do? Go back to the previous one, the I, and then there's a link there, okay? Now I want to write something really obvious to us. Of course, we've done it, but like, I just want to write it because I'm going to use it to further solve this particular question. So remember that you differentiated, okay, tan 3x plus 1, and then you got 3 sec square 3x plus 1. Right. Now, if you come back to this question, they want you to differentiate sec blah, 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 blah. Okay. Right. So if I want to differentiate sec, then it means that I can divide through by 3 because there are no 3. You see this 3 that you see here, it is not there. So I want to divide both sides by 3. Okay, so that means that if I differentiate 1/3 tan 3x plus 1, I will get sec square 3x plus 1. Okay, so that is what it means. Now, why am I doing this? Now, check this now. If we come here and we write the integral of from pi to 10 to pi to 12 on sec square 3x plus 1 over 2 minus, I'm going to split this, okay, minus the integral from pi to 10 of here all the way of negative, that's sine x dx. Okay, should I split it? Okay, now if I told you that if I integrate this, then I'm going to get this as my answer, right? And this particular thing here is what we are seeing right here. Okay, but now before you even see it more clearly, why don't we factor out half? So you're going to have half out, then you have the integral of sec square 3x plus 1 dx, and then you are doing it from pi on 10 all the way to pi on 12. Okay, so now you see it clearly. Then you have the same thing, pi on 12 sine x dx. Okay, so what is the best thing to do right now? Well, you know that there's a relationship that you have already created from the previous side. Okay, so you know when I integrate sec blah blah blah, this is what I get. So that's what you put down. So you have let me use maybe black. So you have half, then you have 1/3 tan 3x plus 1. Okay, and that is from pi here all the way to this. Okay, now hold on. The next thing that you want to do is to integrate sine. Maybe you are wondering, if I integrate sine, what do I get? Is it cos or what? The positive? You just need to know what happens when you differentiate cos. Okay, check this now. If I differentiate cos, I'll get negative sine. Okay, so that means that if I integrate negative sine, all right, I'm going to get cos. So that means that if you integrate sine, okay, when you integrate sine, you are going to get negative cos x. Okay, that's if you divide through by the negative sign. Great. So that means that your answer should be negative cos x. But remember that, okay, let me write this in a different color, negative cos x. So that means you are going to have a positive value. Okay, if you like, you can just keep it like this. And then from here to there, I wanted to multiply that by the negative and just write positive, but you can also leave it like that. Okay, so now you have been able to integrate it well. All that is left with calculator work. You put these things there and you are good to go. Okay, so yeah, sure. So let's do it. I'm just going to put the whole thing on the calculator with the first part. Okay, so if I have, I'm going to grab my calculator. Okay, so you should grab yours, and then first make sure that you change the degrees to radians. Okay, it's very important. Some of you will be doing the right thing, but unfortunately you are working in the wrong angle measure. Okay, you guys, I mean, let's be vigilant. Okay, so 1/3 tan 3 pi, that's I'm going to put pi on 10 there, so I'm going to get 3 pi on 10. That's 3 pi on 10 plus 1, and that, according to the calculator, I get a very weird value. That's negative 0.8551. I'm going to use just 4 decimal places. Okay, and then I'm going to minus, make it subtract, and that is 1/3 times tan 3. That's definitely going to be 3 pi on 12. 3 pi on 12. Okay, be really vigilant here, because sometimes you are doing the right thing. Okay, so that is actually a negative value. Quite interesting. Negative 1.5293. So like I was saying, sometimes we are doing the right thing, just that student being student, we make mistakes that we shouldn't make. It happens. Now you put it in the negative cos. You have pi on 10 and that will give you negative 0.9511 minus, okay, minus, the next thing is negative cos pi on 12, and that is also negative, okay, 0.9659. Great. So I mean, these are going to be easy. I'm just going to do the first bracket together with this particular half, okay. So I'm going to have 0.5 into bracket negative 0.8551 minus, so that's plus 1.5293, and that is going to give me 0.3371 minus, now I have negative 0.59511 plus 0.9659. I hope I've input all the correct figures that I'm reading with my lips. Yep, and I'm going to have 0.0148. So now I can just do my subtraction. Okay, and then according to my calculation, I get 0.322. All right, it's 3223. But due to, Cambridge likes us to write our answer in 3 significant figures, so I'm just going to clean the last one. Okay, so this is our answer. All right, so that's it basically. Then we have another question here. At a glance, you might think that, whoa, this is difficult, but well, it's not. Okay, so if you have the integral of e to the power x plus 1 all to the power 3. Okay, remember indices, right? If I have a to the power n all times m is basically a m n, right? So you multiply the powers. So do that. Okay, it's really simple. So that means you have e to the power 3x plus 3. Okay, so if I integrate this guy, you get, if you integrate the exponential function, you get the same thing. Okay, the only difference is that you have to divide it by the coefficient of the extent, which is 3. Okay, and then you add plus c. Voila, you are done. You have your 2 marks to play with. Okay, then they said that differentiate this argument. So this product, 2 functions that are what multiplying, and then they are formed a composite. Okay, this particular product, and then they want us to differentiate it. Do you recall the how we actually differentiate product? Keep one constant, differentiate the other, plus keep the other constant, differentiate. I mean, you get the idea. So we start with the first one, which is x. I'm going to keep x constant. I'm going to differentiate sine 4x. So if I differentiate sine 4x, I'm actually going to get cos 4x. But if you are not done, you go into the 4x and you differentiate that angular measure there. You have to differentiate it. Okay, so if you differentiate 4x, you're going to get 4. Okay, plus. Now I'm going to keep sine 4x constant and differentiate the x. If you differentiate the x, you get 1. So your answer is basically 4x cos 4x plus sine 4x. All right. Now, this is really beautiful. They want us to show that this whole thing is equal to that. Okay. But one key word is enhance. It means that has something to do with the previous. Like I told you earlier, Cambridge, they have a particular way of setting questions. And this worksheet is really current. I think it's from 2019 all the way to 2021. So this is how Cambridge is thinking now, okay? So they like this particular question. So look out for those ones, especially with my friends who are going to write the October-November series, okay? All the best to you. That doesn't mean that I do not regard those who wrote February and then January, the June series. Point is, you've written it and your results have come out, and those that I've heard from, you did well, so thumbs up. Okay, now, like I did in the first one, you need to understand that something has happened here, okay? So this is what happened. With the first one, you argue that when you differentiate x sine 4x, you will get 4x cos 4x plus x, this guy. Okay, all right, then that's it. So In other words, if I integrate this whole thing, this should be my answer, right? Yeah, because differentiation and derivative are anti of themselves. All right, good. So using that thinking, what is the question actually wanting us to do? The question wants us to integrate this part, okay? So split this whole thing. So that means I have x sine 4x, okay? In fact, let me actually do this part here. So if I integrate 4x cos 4x plus sine 4x dx, it should give me x sine 4x. Okay, so if I split, I'm going to have the integral of 4x cos 4x plus the integral of 4x sine 4x dx. Okay, so just let me put dx here. Good, it's equal to this. Okay, then move the integral of sine 4x dx to the other side. So you are going to have the integral of 4x cos 4x dx is equal to x sine 4x minus the integral of sine 4x dx. All right, pretty cool. So that means that whatever they wanted you to integrate, okay, is right there. So I'm just basically going to integrate this guy and I'm good to go, okay? And I will do a small thing in my head. No, okay, I'll just put it on the paper so that you see how it's done. Honestly, I do not remember what the integral of sine is. I don't know. But what I do know is when I differentiate cos, what do I get? Okay, so I always learn from differentiation. I don't keep these things in head. So if you want to go my way, it's cool. Now check this now. If I differentiate cos x, what do I get? Negative sine x. Okay, so that means that if I integrate negative sine x, my answer is going to be cos x. So that means that actually when I integrate sine x, only sine x, not negative sine x, I'm going to get negative cos x. Okay, once I've established this thing in my head, it takes me seconds. All right, then I can go ahead and then solve the question. So that's what I do. Like I said, I don't know offhand what this will be, but I always go back to differentiation, differentiate a few things, and then reverse the process to get, the integral side of it, and I use it in my calculations. That's what I do. So if you like, you can borrow this particular idea. So now, if I integrate this guy sine 4x, I'm going to get negative cos. Okay, so that should be negative cos 4x. All right, but you must divide it by coefficient of the x term. That's 4, right? But you would write plus c, okay, but you don't have to, because if you look at the question that they gave us, it's a definite integral. Okay, so I'm just going to kindly remove this guy from there. It is highly irrelevant. Okay, so now all that I have to do is to put the limits on it from pi on 3 to pi on 4. Okay, and then let's see. So that means that it's from pi on 3 to pi on 4. Now remember that they said show that it is going to give you this. So please don't be quick to write your answers in decimals, okay? Don't. Now let's start with the first part. I'm just going to put the whole function in the calculator. X, make sure that it's in radians though. X sine 4x minus, okay, don't do minus, do it plus, because you have minus here, minus there, so just put plus there. So plus cos 4x, okay, over 4. All right, now you solve it. When your value is pi on 3, what you get is going to be a decimal. Holy crap. Okay, so if it's going to be a decimal, then I have to be careful here. Okay, so now I'm just going to do it one by one and see how things will go. I don't want to get a decimal. Okay, so I'll just do the x sine 4x. Okay, I'm just going to put pi on 3 there, and that is also going to give me a decimal. So let me just work it out myself. So that'll be 4 pi sine 4 pi on 3. What is sine 4 pi on 3? Sine 4 pi on 3, that is actually negative root 3 over 2. Okay, so should I clean it? Yeah, maybe. You get the idea. I mean, it will give you negative root 3 on 2. Then I have plus. I'll do cos 4 pi. Cos 4 pi is cos 4, so that would be 4 pi on 3. Cos 4 pi on 3, and that, ladies and gentlemen, will give me negative half. So I have negative half over 4 here. Okay, I'm done with the first one. Minus. Now I'm going to use pi on 4. So that should be pi on 4 sine 4 pi on 4. So that's sine pi. Now sine pi is what exactly? Is it 0? Yeah, 0. So you're going to have 0 here. Then you would have plus 4. That's also cos pi. I think cos pi is 1, right? Cos pi is negative 1 actually. Wow. So negative 1 over 4. Okay. So the next thing is that we expand. We are going to get negative root 3 pi on 6 plus. Now you have negative 0.5 divided by 4, giving you negative 1 over 8. Okay, then we have minus, but check this thing out. This whole thing is 0. This is negative, this is negative, so that's positive. Okay, so just put plus 1 over 4. All right, so this whole thing, I mean, don't be quick to put the answer down. Relax, and then let's see what's happening. We are supposed to get 1/8 minus that. Okay, cool. So we would get negative 1/8 plus 4. We can do that on the calculator and see. Negative 1 over 8 plus 1 over 4. Calculator tells me my answer is positive 1 over 8. So I have 1 over 8 minus. Then I bring this guy there, minus root 3 on 6 pi. Right, so now this is what I have. We should go and check the answer that they want us to get. They want us to get 1 over 8 minus pi root 3 over 6. Basically, that's it, but I wrote it in a different way. If you're uncomfortable about that, why not? I mean, write it in the way that the examiner wants. Pi root 3 on 6. That's also fine, okay? And how many marks for this? I mean, it looks long. 4 marks. Well, I think they are just cheating us. So let's continue with question 11. So the question says that the volume and surface area of a sphere are given by this and that. But if you look at the shape very well, okay, it's actually a hemisphere and then a cylinder. So what I want you to do is to quickly change these things, okay, because you are going to make a mistake. You are going to use them in your work. All right. So now, if you divide, this is for hemisphere, for a full sphere. So let's divide that by 2. So we're going to get 4 over 6 pi r cube. And then this is going to give us 2 pi r square. Okay. Very, very important. Okay. I'm speaking from experience. It happens. All right. Then the next thing that you want to do is to continue with the preamble and see what is there. Well, this diagram shows a solid made up of a hemisphere, like I said. So you need to divide that by 2, and then a cylinder. But their radii is actually x. And then the volume of this shape is what? Is 500. So now that they have given you the volume, that's where you start from. What do they want? They want you to show that the surface area. So we can do this thing side by side, okay? Start from the surface area and see what happens. Well, the surface area, let's call it S, because the question says that show that is this. So we call it X. Is going to be the surface area of the cylinder, okay? But mind you, this cylinder is actually how do I even say? See, the hemisphere is sitting on. So if I mean this is my music box, okay. So let's say this is a cylinder. Of course, it's in the shape of a cylinder. So if this is it, now remember that the hemisphere is sitting on top of it. So the surface area is the curved surface area of the cylinder, the base of the cylinder, and then the surface area of the hemisphere. Okay, you will not use the closing part of the cylinder. It wouldn't make sense because the hemisphere is already occupying that place. Okay, so cylinder has the base, so the area of the base is pi r square, but the radius is x, so let's just write this pi x square, followed by the curved surface, okay, which is 2 pi rh, okay, but it's going to be 2 pi x h. What is h? H is y, all right, then plus the surface area of a hemisphere, and remember that they gave you 4 pi, okay, but since we are dealing with a hemisphere, so it's 2 pi r square, but r is x, so 2 pi x square. Even from here we can just add this to that, okay, and then we can get like 3 pi x square plus 2 pi x y. Okay, now if you check this now, it doesn't work with what they want. No. So, and in fact, if you look at the question, it doesn't have any y, but we have a y. So that means that we are not done. Okay, we started really well, but there's something else that we need to factor into. So we go back to the question to read, and then you realize that they gave us a volume. Okay, they gave us a volume. So let's work with it. Okay, so let me clean this. Do I have to? No. Let me just, because we would definitely use it again. So let me maybe put it maybe here. Yeah. So now let's go and work with the volume. So the volume would be volume of a cylinder plus the volume of a hemisphere, not a sphere, okay? So for the volume of a hemisphere, that will be 4 on 6 pi. So that's what I've actually written here. Pi r square cube, okay, but we are going to use x cube, okay, because the radius is x. Then we have the volume of a cylinder, which is 2 pi r square, okay. Oh, sorry. It's actually pi r square. So pi r square h. So I'm going to write pi, instead of r, I'll write x square, and then the h is y, okay. And this thing is equal to 500. All right, but now you know this particular y here, and there's a y here, so make y the subject from the volume, and then we dump it straight over there. So y is actually going to be 500. Can I just have it here like 500? Okay, 500 minus 4 on 6 pi x cube, okay, all divided by 1 over pi x squared. All right, I hope I've done the change of subject well. So in other words, I have 500 over pi x squared minus, now if I divide this expression here by pi x squared, I should get something like, if I simplify, I'm going to have 2 over 3, okay, x, yeah, basically 2 over 3x. So that's what y is. I'm going to dump this thing right here. So I'm going to have 3 pi x squared plus 2 pi x into brackets 500 over pi x squared minus 2 on 3x. Okay, and that will give me Okay, let's expand. Pi x squared plus, so this would be 1000 over x minus, then 2 pi x times that should give us 4 pi x squared over 3. Okay, so now we can work with the s squares, and that is going to be this x squared or minus 4 pi x squared over 3 plus 1000 over x. Okay, so now note that they gave us a part to work this whole thing with. I don't even know why I'm working everything up here, so I'm just going to copy this, take it down there, and then we will deal with it. So maybe we can put it here. Okay, all right, so now we can work well here. So that should be, if we are working with the x squares, we should get like 9 pi x squared, okay, over minus 4 pi x squared all over what, 3, right? Sure. Plus 1000 over x. Okay, this is the surface area. So s is now 5 pi x squared over 3 plus 1000 over x. Okay, sure. It seems like we got what they wanted. So this is how you actually go about it. You use everything given in the preamble to solve this particular question. Okay. Then the next thing that actually this is a May June 22. It's really current 2021. They said that x can vary. Given that x can vary and that s has a minimum value, find the value of x for which x is what is minimum. So if we grab this particular thing that we got, that s is equal to 5 over 3 pi x, is it square or cube? Pi x square, okay, plus 1000 over x. If we grab this, okay, and now they want us to show that they are saying that x can vary. Okay, so that means that you can have ds dx, okay, because it can vary. It means that you can differentiate with respect to that. Okay, so and now they are saying that there's a minimum value. So I mean, it doesn't matter. Let's differentiate it. Dx dx will give us 10 over 3 pi x, right? And then this is going to be check this thing out. Don't get confused here. You have something like this, so you're going to have negative 1000 x negative 2. Okay, so basically something like this. All right, so I'm just going to put this thing there. So I have negative 1000 over x squared. Okay, so let me clean this part. It was just to cement the idea. Okay, so now at the minimum or at the maximum, I mean, when we differentiate, we normally equate it to 0. Okay, so I have equated it to 0. Let's try and solve for x. Okay, so if I multiply 3 by x, I'm going to have actually by x squared, or you can just decide to multiply 3 by 3 first. Okay, you have 3 here, you have times 3 there, you have times 3 here, and that's going to give you 10 pi x minus 3000 over x squared is equal to 0. Then you can later on decide to multiply 3 by x squared. So this place times x squared, this whole thing times x squared, this also times x squared. All right, and then you are going to have 10 pi x cubed minus 3000 is equal to 0. Okay, then you have s cubed is equal to 3000 over 10 pi. Then you take the cubic root, and then that will be 3000 over 10 pi. Okay, then you take your calculator. make sure that it is not in radians, okay? Right, this is not a circular measure question, so please change it from radians to the normal degrees. So let me change this to degrees. So I have the cubic root of 3000 over 10 pi. 10 pi. Oh, come on. Pi, okay. And the calculator tells me that I have 4.57. Okay, 3SF. Okay, so that's basically the value of x. Now, you may be wondering, oh, the minimum value they are talking about. Well, they are trying to tell you that should you differentiate this thing to the second derivative, okay, you are going to get a negative. Okay, so that's basically what they are saying. But actually, it's going to be a positive, yes. So I have a minimum. But you don't have to investigate that. They just want to find the value of x. So you just solve it out, and then you are good to go. Okay, so let's solve this question. That'll be the last question for the day. Okay, and then the rest, sure, you can give it a try. So this is also May, June 2021. Paper, is paper what? 2-2. Okay, question 12. Right, so let's see how we are actually going to solve this particular question. It says that the diagram shows part of a curve. Okay, there's a curve and then there's a line. The curve meets the y-axis at point A. Hold on, let's go to point A. On the y-axis, x is 0, so that means that this whole thing become what? 1, right? So it means that A is 0, 1. Okay, I like to solve questions like this. Then okay, let's continue. The line meets the x-axis at B. The line meets the x-axis at B. Well, take the line, take the line, take the line. This is the line. Okay. At the x-axis, y is equal to 0, right? So if this is equal to 0, then you have this. That means x is what? 1. So B is actually 1, 0. Great. Now what do they want? Okay, find the coordinate of. And then wait. The line and the curve intersect at point C. So this is it. So we can also look for the coordinate of C easily. Okay. So that would mean that we have to equate them. Okay. But maybe the question like that. Verify that the x coordinate. Okay, hold on. They want us to find the coordinate of A and B. Okay, A is, we have already found it, 0, 1. And B is 1, 0. Cool. Verify that C is what? The x coordinate of C is 2. So you just equate the two. But the line, the curve is actually 1 over 2x plus 1. And then the line is 5y x minus 1. So just make y the subject from here. You are going to have x minus 1 over 5. Great. Equate them. So you have 1 over 2x plus 1, right? And then is it plus 1 or minus 1? It's 1. Okay. You have x minus 1 over 5. All right. So when you solve, you're going to have 2x squared minus 2x plus x minus 1 is equal to 5. And then that will give you 2x squared minus x minus 6 is equal to 0, right? Something like that. At this point, I'm just going to use the calculator to solve it. I'm very tired, sorry. 3, okay. So 2, negative 1, negative 6. Calculator says x is equal to 2, and then x is equal to negative 1.5. Okay, now you may be wondering, which one do you choose? Well, come back. If this is 0, it means all the values to the right of 0 is positive. So you can show that, therefore, x equals 2. You choose the positive one. Okay, the positive one. Because C happens to be on the right side of 0. Then they want you to find the exact area. You see, finding the area is okay, but this saying exact means they don't want to see anything being what? A decimal. Okay, so if you get a third, leave your answer in third. If you don't get a third and you get something else, you leave your answer like that. Okay, now what do they want? So let's say, so B. Okay, let's solve it. The area. We go back to the question. So they want the area of the shaded region, right? Good. Now you know this is 2, don't you? You do. If that is 2, this is my plan. Okay, I want you to find this area of the triangle here, all right, so that I can subtract it from the integral of the curve from 0 all the way to 2. Then I'm good to go. All right, so and you know how to find the area of a triangle, half base times height. Now we need to know the height. So if I put 2 into probably the curve, okay, I'm going to have 1 over 2 into 2 plus 1, that will be 1 over 5. So the height itself is 1 over 5. Okay, so that's the plan. So now I'm going to just integrate the curve. So I'm going to integrate 1 over 2x plus 1 dx from 0 all the way to 2, okay, all the way to this place to 2. Then I'm going to subtract the area of the triangle, which is half times the base times the height. Okay, so that's the plan. Now this guy looks quite interesting, so why don't we if we write it in this way, you realize that there's going to be a problem, because when you integrate such a thing, you're going to add plus 1, you have negative plus 1, so basically you're going to get 0 over there. So that means that there's an issue. Okay, now what I want you to do is to note that what you are dealing with here has a lane. Okay, has a lane in its argument. So what you basically want to do is to consider that. So you have lane 2x plus 1, okay, 2x plus 1, okay, all over 2. Always the coefficient of the x term comes to divide it. So if you are in doubt, you can differentiate that to see if you get the function, right? Why not? So you have ln 2x plus 1 over 2. If you differentiate this, okay, the derivative of this is going to give you 1 over 2x plus 2, plus 1, okay, times 2. Now you have you can write 2 over 2x plus 1, okay, but if you compare what you have here, okay, this guy with the function itself, you would see that, okay, they look really similar, right? So what do I do to make it really equal? It means you have to multiply by half. Okay, so you multiply this by half, but it is not this function that you're going to multiply by half. You are going to rather multiply what you have here, okay, by half. Okay, that's the function itself. That's where this half is coming from, basically. All right, so if you differentiate, basically what I'm trying to say, if you differentiate 2x ln this guy, you are going to have this, okay, times 2, sure. But if you want to go back, then you have to multiply by half, and that's where this particular 2 is coming from. So that's the plan that we use. All right, so you have this plus maybe a certain c, but you don't want to bring the c since you have a definite integral you are working with. So from 0 all the way to 2, and then this is going to just give you 1 over 5, right, or 0.2, and then you just put it in there. So you have ln. If I put 2 there, I'm going to get 4, then that's 5 over 2 minus ln 1 over 2, okay, minus 1 over 5. But I think ln 1 is actually 0, if I remember correctly. Yeah, 0. So that means I have ln 5 over 2 minus 1 over 5. So you leave your answer in this form. Don't put it on calculator to see that, okay, what do I get and what? No, because they said that leave your answer in the exact form. So you leave it in this particular form, okay? And you are good to go. Let me check something here. Okay, so that's fine. All right. Hey, wait. I just realized something. So I was arguing with a triangle that is half base times the height, right? But what is that? From here to here is 1 unit, but I chose 2. That's wrong. So this is 1 unit. Okay, so that means that I'm going to have 10 here, and this is 10. Okay. Yeah, I'm sure some of you will put it in the comment section. Yeah. Okay, so that's it. Great. Right, so basically this is where I want to end it. I mean, we've spent over an hour, so the rest, I mean, just put it there. We will all talk about it. We know how to solve it. So in my next video, I'm going to talk about a small change. I'm going to talk about rate of change and how to solve questions on them. Right, so until we meet again, take care of yourself. Bye for now.